Hello and welcome. My name is Lewis, and here today we will be talking about RS232. At the end of the video, I will give a demonstration using a laptop computer to communicate with a 9S12 G128 microcontroller using a RS232 cable to USB. So let's jump right in. Electronic data communications between elements will generally fall into two broad categories: single-ended, like the RS232, or differential. RS232 was introduced in 1962, and despite rumors for its early downfall, has remained widely used throughout the industry. Independent channels are established for two-way communications, otherwise known as a full duplex. RS232 signals are represented by voltage levels with respect to a system common. The idle state, mark, has a signal level negative with respect to common, and the active state, space, has a signal level positive with respect to common. The RS232 interface presupposes a common ground between the DTE, data terminal equipment, such as a computer, and the DCE, data communication equipment, such as a modem or microcontroller. This is a reasonable assumption when a short cable connects the DTE to the DCE, but with a longer line or connection, devices that may be on different electrical buses with different grounds, this may not be true. RS232 data is bipolar. With today's technology, modern computer equipment ignores negative voltage level and accepts a zero voltage level as the off state. That being said, an on state may be achieved with lesser positive potential. This means circuits powered by 5 volts DC are capable of driving RS232 circuits directly. However, the overall range that the RS232 signal may be transmitted or received may be noticeably reduced. As you can see from this image, the basic RS232 cable indicates that these three pins, transmit, abbreviated TX, receive, abbreviated RX, and ground, abbreviated GND, is the basic connection type. Here we have the male pin layout for the RS232, and as you can see, pin 2 is used for receive, pin 3 is used for transmit, and pin 5 for ground. For the female pin layout, pin 2 is used for transmit, pin 3 is used for receive, and pin 5 still for ground. In this picture, I show the cable I used to connect from the microcontroller to the next cable here, which is the RS232 cable to USB, which will connect to my computer. The port on the microcontroller, located in the bottom middle of the screen, sort of looks like two rows of 5 spikes. As you can see here, I have made the cable connection. Now that I have my setup ready and the program is running, I'm ready to get the demonstration going. The program I am demonstrating uses the number 1 to retrieve data. Any other key pressed will be stored. When I press 1, there is no data stored, so the queue empty is presented. For each key I press, the data is stored and an X is shown on the microcontroller's LCD. When the queue is full, it is indicated on the LCD screen. As I press 1 to retrieve the data, each previously stored key is revealed.